For centuries, mankind has gazed at the night sky, filled with questions about the enigmas of the universe. In the 20th century, scientists proposed the theory we know today as the Big Bang theory. This theory struggled to answer crucial questions about the origin, development, and expansion of the universe. However, recent research has added even more complexity to this mystery. In 2023, NASA's James Webb Space Telescope made an astonishing discovery. It detected celestial objects that were apparently older than the universe itself. This revelation has left scientists baffled and questioning the possibility that a star could exist for a period of time longer than the universe itself. Does this call into question our current understanding of the cosmos? Might it require the conception of a new model to give meaning to this enigma? These questions and many more will be answered in this video. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. About 200 light-years away, near the coasts of Asan-Lee, lies an ancient star known as HD 140283. The surprisingly high velocity of the star, HD 140283, at 44.83 km per hour gives us valuable clues about its dramatic history. About 1 billion years ago, at that time, our Milky Way was in the process of formation and merged with a dwarf galaxy that served as its home. However, the most amazing thing about HD 140283 isn't its speed but its age. The star is among the oldest celestial objects we have had the privilege of observing and has been nicknamed Methuselah in reference to the biblical character, who, according to the legend, lived 969 years. Initially, estimates placed the age at a staggering 16 billion years. But the most recent estimates place it at 14.46 billion years, with a margin of error of 800 million years. This figure poses a considerable conundrum, as it contrasts with the age of the universe, which we determine through observations of the cosmic microwave background, and which stands at approximately 13.8 billion years. The question arises: how can a star be older than the universe itself? This seems impossible to the naked eye. This paradox has raised questions regarding the age of the star, the accuracy of our dating methods, and ultimately the actual age of the universe, inviting further exploration of these cosmic mysteries. First, it is critical to understand that calculating the age of celestial objects represents a considerably complicated task. Stars like our own Sun maintain their temperature and size unchanged for billions of years, making estimating their age extremely difficult. Astronomers rely on subtle changes in the brightness and color of stars over time and then compare these measurements to mathematical models that predict how these stars evolve. A crucial indicator for determining the age of a star is its rotation rate over time. Stars slow down, similar to a wheel slowing down due to friction. By comparing the rotation rates of stars of different ages, astronomers have established mathematical relationships that allow them to estimate their ages using a method called gyrochronology. The star Methuselah is indeed ancient. In fact, it is the oldest star in the universe, with an age that we can estimate reasonably accurately. Instead of wondering whether it might be more than 2 billion years older than its surroundings, we can approach the problem from a different perspective. Is it possible that the universe is not as young as scientists initially believed? Indeed, it is difficult to comprehend the immensity of 13.8 billion years. If we try to summarize the entire history of the universe in a cosmic calendar, where the Big Bang would be equivalent to the most dazzling New Year's fireworks, Earth, in this escalation, would only join this cosmic celebration at the end of the year. While recorded human history barely spans the last 10 seconds of December 31st Street. Scientists determine the age of the universe by observing the light from stars that were born hundreds of millions of years after the Big Bang as the universe expands, causing a phenomenon known as the redshift. When we evaluate both the observable distance and the universal expansion, a universal age of approximately 13.8 billion years is deduced. However, recent discoveries by researchers at the University of Ottawa raised the possibility that the universe is significantly older. Estimated to be about 26.7 billion years old, University of Ottawa physicist Professor Rajendra Gupta presents a theory that merges Swiss astronomer Fritz Zwicky's 1929 theory with new ideas. This theory suggests that protons lose energy during their journey over vast distances and times. Despite being in contradiction with observable data related to redshift, Gupta proposes that by allowing this theory to coexist with the expansion of the universe, we could reinterpret the redshift as a hybrid phenomenon that is not exclusively due to the expansion. This reinterpretation would increase the estimate of the age of the universe and could offer explanations for long-standing cosmological questions, as well as some recently raised by NASA. NASA's James Webb Space Telescope has been instrumental in arriving at this estimate of 26.7 billion years. Gupta combines the tired light theory with the concept of evolutionary interaction constant, originally proposed by theoretical physicist Paul Dirac, implying that interactions could have undergone changes over time. It is relevant to note that scientists have previously revised the age of the universe on different occasions. For example, in the 1920s, Edwin Hubble claimed that the universe was only 2 billion years old. However, over time, our estimates have improved significantly, doubling the age of the universe. This increase represents an important milestone as astronomers strengthen their understanding of the age of the universe reached in Gupta's work. Regardless of whether we consider the recorded history of humankind to be equivalent to only 10 seconds or 5 seconds in the immense time frame of the universe, what is undeniable is that the universe is an extremely old and amazing place. Its constant expansion leads us away from previous notions about its age. However, there are also remarkable observations concerning our own galaxy, the Milky Way. Recent measurements suggest that stars in the outer regions of our galaxy move at a much slower rate compared to stars in similar locations. This raises a couple of possible explanations for this phenomenon. One is that our galaxy may possess an exceptionally low amount of dark matter, an invisible substance that plays a crucial role in the gravitational structure of cosmic objects. The other possibility is that our understanding of dark matter, including how much of it exists in the universe, may be mainly different from what we have considered so far. This conundrum originates from data collected by the European Space Agency satellite, which provides detailed information about the positions of nearly 2 billion stars in the Milky Way. These data have led astronomers to reconsider their assessments of stellar behavior, particularly in relation to stars in the outer part of our galaxy. The speed at which stars move is an essential indicator for estimating the mass of a galaxy, since the gravitational force affecting each star depends on the total mass of the galaxy. A recent study, based on data collected by the Gaia satellite, calculated that the combined mass of our galaxy, which includes gas, dust, stars, and dark matter, is approximately 200,000 billion times the mass of our Sun. And although this figure is certain, it is about 5 times less than previous estimates. This is due to the fact that the amount of visible material in the Milky Way has inexplicably decreased. A suggestive interpretation of this result is that there may be less dark matter than previously considered. However, measuring the mass of a galaxy is a notoriously complicated task, raising the possibility of uncertainties in the data collected by the Gaia satellite or in the new analysis that has been developed. We will remain alert for new information to keep you up to date. If you liked the video, remember to like and subscribe, and see you in the next one.